So today, as I said, we're looking at two-way tables as a way of summarizing our categorical data. Now, this is pretty straightforward. A lot of this we've already seen before. We're just kind of giving some structure to those details. Remember that categorical data has a label to it. Typically that's a nominal label where it's just a word that describes what's happening in that. But the example I just gave you, 9th, 10th, 11th, 12th grade, okay, those are numerical values that are still serving the purpose as categorical labels. Okay? So be aware that we could still have numerical values representing that categorical data. What's important when you're talking about categorical data is either the count or the percent of the individuals who feel this way or respond this way. Okay, so we're keeping track of those, and we saw that with our z-test for proportions. We're comparing two percentages to each other to see if there was a significant difference. To structure all of these relationships at the same time, we're going to use a two-way table. To talk about the orientation of the two-way table, we're using the rows and the columns, and each of those dimensions has their own variable. So we have an example of a two-way table here. This is some of the demographic information that was asked as part of a survey, looking at young adults and using gender and if they have any college or no college experience, and then referring to their employment status. Do they have a job outside the home? Do they stay at home? Or is there no preference? They don't fall into either one of these categories here. So what are the variables described by this two-way table? Well, going horizontally with the row, we actually kind of have two variables. We have gender and we have education. Okay. No college or some college experience. Going across the top with these columns, we have job, stay home. This is basically employment. That is the main comparison that we have here. And overall, we have an overall total of 1,012 individuals, young adults, that participated in this survey. Now, when we're talking about the structure of these tables, and we'll be using technology, GeoGebra, the calculator, to create these, we need to provide it with the dimensions. So typically we go row by column when describing that. Spelled column wrong. You get the idea. In this case, you do not use the headings. You do not use the totals. Sometimes you'll have like a percent column or a percent row. Do not use that. We are just considering this for our dimensions. So row by column, 4 by 3 would be the dimensions of this two-way table. Yeah. 4 different breakdowns here, 3 different breakdowns vertically for the columns. These next two terms, you don't really need to know them. Again, they are ideas that you already know. You just haven't really applied this label to them. Marginal distribution and conditional distribution. A marginal distribution looks at the overall total and compares a row or column total for a particular variable to that overall total. Okay? We're using percents typically for this representation. So let me give you an example in this case right here. If we were looking at this first row, women with no college background, there were 195 of them. So of the 1,012 individuals that we have, 195 of them were women with no college, which constitutes 19.3%. We could do that with each of these rows by just taking that row total divided by the overall total, and we get all of those percentages that add up to 100%. You can represent this visually with a bar graph or parts of a whole. A pie chart would also be a good representation right here. Flashing back to what we talked about at the very beginning of the year. Now that was a marginal distribution where you're using the total row, or the total for a row or column, to compare that to the entire sample. Conditional distributions kind of are connected to what we talked about with conditional probability. The probability that something happens given that something else has already happened. Probability of B given A. Now, we're not going to get into the equations of any of that in this unit, but to represent this with the tables, we're no longer looking at that overall total. Instead, we're looking at those individual values inside the table and compare them to the row total or the column total. We did some of this during our probability unit. Again, with our example, if we are looking at these women right here, women with no college who have a job outside the home, and of those women with no college, how many of them have a job outside the home? Well, we are now looking at a condition. Rather than just people in this sample, we're looking at just the row total, the women with no college, 195 of them. Of those 195, 81 of them had a job outside the home. There's a conditional probability calculation, 81 over 195, 41.5%. 104 out of 195 stay at home, 53.3%. 10 out of 195, 5.1%, have no preference. We could do the same thing for the men. And we have a new visualization here that we didn't really talk about in the beginning of the year. This is called a stacked bar chart or a stacked bar graph. It's kind of like a bar graph and a pie chart in one, in that it allows you to make that men to women comparison, but it allows you to show the distributions within each. Okay? You have the full 100% of women with no college represented on the bar. But those with a job outside the home, that's the blue. And you can see how the women compare to the men. The red represents the women or the people who stay home. Okay? That's a larger proportion for the women compared to the men. And then the no preference, that's relatively the same. When we were doing our z-test for proportions, there's a z-test to compare if there's a significant difference between the two blues, between the two reds, between the two greens. But they're all kind of conditionally related to one another, so we may not have that independence that was necessary for those tests. What we're setting the table for is to do a chi-square test for a relationship. Is there a relationship between gender with level of education and the employment? It allows us to consider all of these together. And at the end of our hypothesis test, our conclusion is there's no relationship between gender with education and employment, or there is a relationship. And if there is a relationship, then we can kind of go into it further and maybe start to do those individual z-tests for proportions. Okay? But that we'll get into tomorrow. For right now, we're just kind of looking at these tables and how they can kind of summarize our data, because it's really important for us to be able to, or for us to be familiar with them for our analysis. Any questions here? All right. as I said, I have a brief against all odds that I want to show you to just kind of go over some of these ideas and give you another example of how these tables could be used. So let me get that started here.